Hello all too. I've shown this design before. It's a two-speed transmission for electric vehicles. This gear is first gear, this gear is second gear. Conventional transmissions are complex. Clutches, hydraulic systems, synchronizers, etc. These are essential transmission components. My technology enables shifting with only a few components. This can be a major advantage for electric vehicles. This three-stage planetary gear system has its advantages. This makes it easy to implement a 3 or 4-speed transmission. The approach I'm introducing today is new. For most electric mobility applications, a 2-speed transmission is sufficient. Therefore, it's better to make the 2-speed design even simpler than it is now. This is also a 2-speed transmission for electric vehicles. This gear is first gear, this gear is second gear, this is the main shaft. It is directly connected to the motor and rotates with it. The two gears on the main shaft rotate freely. Locking either of these two gears changes the speed. This black component is a small BLDC motor. The direction of this motor determines which gear is selected. Because shifting is done with just this small motor, the structure is very simple. The pawls in the shaft lock the gears. In this position, the pawl protrudes from the shaft. In this position, the pawl is retracted into the shaft. When the pawl protrudes like this, the gear is locked. When the pawl is retracted into the shaft, the gear rotates freely. Inside the shaft is a mechanism that extends and retracts the pawls. Those components are driven by the BLDC motor. There are supports that actuate the pawls. When the supports remain aligned, the pawls protrude. This securely locks the gear. When the supports tilt like this, the pawls retract into the shaft. The slider is the component that moves the supports. The slider can move back and forth like this. This causes the supports to either remain upright or tilt. The motor shaft acts as a screw. The slider moves back and forth depending on the motor's direction of rotation. It's a very simple mechanism. The motor has a simple roll, and so does the slider. Simply tilting or straightening the support completes the shift. This is a 3D printed prototype of a 2-speed motorcycle transmission. I'll fast forward for quicker viewing. This test is to verify the operating mechanism. Compared to the previous 3-speed design, this mechanism is much simpler. The advent of 3D printing has greatly accelerated development. The printing precision is better than I expected. Machining it from metal would cost thousands of dollars and take several months. In most cases, assembly requires multiple revisions, making the process take even longer. With 3D printing, design revisions can be completed within just a few days. This is the 3-speed motorcycle transmission I introduced previously. First gear, second gear, third gear. There is a significant difference compared to the gearbox I built this time. I didn't expect the size difference to be this significant. I changed it from a 3-speed to a 2-speed gearbox and reduced the number of gears. The size difference is much greater than I expected. Despite its compact size, I believe it will be practical for real-world use. It should be sufficient for small electric vehicles. The channel-based design is ideal for 3 or 4-speed transmissions. It's ideal for high-power applications or heavy-duty vehicles. I believe this 2-speed design will be used in many more applications. Most mobility applications only need 2 speeds. A simple 2-speed design is definitely the right solution. First gear, second gear. First gear, second gear. A transmission is inherently a complex mechanical system: clutch, hydraulic system, synchronizer. These components are both complex and expensive. This design doesn't require any of them. All it needs is a few small components. A small motor is all that's needed. This 2-speed transmission redefines what a transmission can be. It minimizes the disadvantages typically associated with transmissions. It's especially well suited to inverter control. The benefits are clear. Battery efficiency increases. It can also lower the vehicle's manufacturing cost. It is expected to be used in a wide variety of vehicles.